Okay, for 4b, we have a function g of t is equal to 75 root t minus 3t plus 100. And that function is for gallons per minute. So that is a rate function. And then it says how many gallons of water have been pumped out by the reservoir at time noon. And so we have water pumped in at a rate of this. And by time noon, starting at 9, we got, so that's 3 hours. And t is between, minutes. So 3 hours in minutes, that's 180 minutes. That would be an integral from 0 to 180 of that 75 root t minus 3t plus 100 dt. So that's part A. Part B, we have to make one presumption, and that is, since we're starting pumping out, the number of gallons pumped out initially, in other words, if I create a function, let's call that big G, just to make the consistency. So the number of gallons pumped out at time 0 is equal to 0, which means that if I now create a function big G of x, that would be equal to big G of 0 plus the integral from 0 to x of little g of t dt. This is that most important formula in all of calculus. And the question is actually saying that this right here is going to be equal to 30,000. I want to solve for what x makes that true. So I can say 30,000 is equal to g of 0, which is 0, plus the integral from 0 to x of g of t, which is that 75 root t minus 3t plus 100 dt. Well, I can just set these equal in graph, or I can use the graphing calculator and set them equal to 0. So I think that according to your question, that's what I've done. I've said I need to figure out where this is happening. So why don't we just say at what x is the integral from 0 to x of 75 root t minus 3t plus 100 dt minus 30,000 equal to 0. So if we can graph this in the graphing calculator and figure out what's going on there, then okay. So I'm going to go ahead and do that. We're going to go into the graph section and tab. This is going to be a tricky entry because of how this doesn't like me. But we're going to do the integral from 0 to x. So x is my upper limit of, that would be 75 times the square root of t, right? Then minus 3t plus 100, and arrow over and put the t in here, and then kind of stay to the right, minus 30,000. Okay, and then it graphs, and we want to zoom out of this graph pretty substantially, so we're going to go, let's go maybe 50,000. Oh, don't need to go that large, so let's maybe go 5,000. Closer, maybe go 2,000. And just for kicks, let's try to make our vertical be a little bit better. So I'm going to tab all the way up to here. Just kind of pick something like 10,000. Nope, need to be much taller than that. 100,000. Getting better. Maybe 1 million. And that's way too tall, so maybe let's go 300,000. There we go. Of course, now I just want to make my below axis be better. So maybe negative 100,000. There. Now I can do the intercepts a little bit better. So let's see, at what time will the gallons be pumped? Oh, my time is from 0 to 600, so let's make this be 600. And now I've actually got the domain correct. Now I can go menu, analyze graph, intersect. Pick this graph. Oh, not intersect, sorry, zeros. Menu, analyze graph, 0, left, right, and I get this. And if I check the answer key, see, yep, 72.0, so 72 minutes. Looks like we're good.